And thank you so much for the invitation. I'm really happy to be here and start this warm-up. And the title of my talk will be What's Like to Do Consulting as a Complex Systems Researcher Who Wants to Be a Consultant. This is based on my experience. So I hope you can see my screen. I guess this is fine. Perfect. Okay. So this is based on my experience, and just to present a little bit of myself, I have a PhD in complex systems simulation, but my background is actually in physics, my training. I've been at the Santa Fe Institute, and I highly recommend that experience. I'm a member of the Institute of Physics. In total, I have 9 years of experience in research around the topic of complex networks. I have 38 papers, and I've given also almost 50 talks now. And this talk in particular will be about my experience at Complex Science Consulting, scientific business that I started in 2018 and that is still running in synergy with my current position at Exeter. So at Complex Science Consulting, I worked mainly in 3 different areas, 3 flagship projects: big data for human cognition, language processing for social media analysis, and also achieving innovation in education. And I collaborated with several research institutions. I kept performing research, even as a scientific consultant, but I also consulted for several startups, for industry, for companies, and also for universities and other types of consulting institutions like chambers of commerce. So this talk will be based on my personal experience, and I will try to give you a little bit of a few tips and indications about the pros and cons of doing scientific consulting as a complex systems researcher. But let's start from the basics. What's scientific consultancy in itself? Well, there is a customer. It might be a company, it might be another type, a university, a research group. They have a challenge. The role of the scientific consultant is to manage this challenge in order to come up with a solution to it. The management of this challenge is very similar to project management, so that the consultant needs to come up with a structured approach, understand the starting data or the starting situation that the customer works with, then trying to address it with some novel methodologies that are not easily available. Companies and other types of customers in general resort to scientific consultants because they don't have the time to hire an employee, train them, and make them capable of solving the question or the challenge. The customer doesn't have time, so they look for a very specific skill set, an expert already in the field that can do this. In general, the customer is not really interested in the research process of this whole management procedure, but rather in its outputs. And we will be talking about this more in the next few slides. What are the key responsibilities of the scientific consultant? They are quite close to writing a scientific paper, because the consultant needs to define a complex problem, understand what the customer wants, implement a quantitative structured approach to solving the problem. It might be, for instance, analyzing a data set or extracting knowledge from a collection of texts. The consultant needs to also consult, so provide recommended action plans, for instance, provide a wide set of options, and then let the customer decide how to perform better, how to address better the challenge. At the end, it's extremely important to evaluate and test the solution that has been reported, very much like interpreting and discussing the limitations of a model at the end of a scientific paper. And so this is a little bit of a general outline. You might know also some scientific consultants, even though you don't know that they actually consulted for companies. For instance, both Richard Feynman and Stephen Wolfram worked as scientific consultants. Now, we know that Stephen Wolfram is the head of Wolfram Research, so we all know that it definitely works in scientific consulting. But for instance, personally, I didn't know that Professor Feynman, that we know as a brilliant mind in physics, also worked as a scientific consultant for a company called Thinking Machines Corporation that worked in the 80s and in the 90s. and that produced the first machines on the market that were capable of artificial intelligence and soft computing. So it is quite remarkable that scientific consulting is also performed by high level professors and academics. There are some important details about the figure of the scientific consultant. This job definitely comes with flexibility because consultants are not employees of the customer. They have to manage their own office, their own equipment, so their own timetable. So this comes with a certain flexibility in terms of managing the workload. However, this has also some financial consequences in that it's extremely important to set up how much you are going to be paid for your own project. You can do this by setting up hourly or daily rates, or you can also design some overall project fees that cover the whole project management of the scientific consulting that you are doing. Related to this, it's extremely important, since you are paid on time and effort, to carefully plan the time and effort that you will put into achieving a certain project. So that for a scientific consultant, it's extremely important to do careful planning. It's important not to do like the girls are doing here in this yrCSS comic. It's important to come up with the good approximate indications of how much effort and how much will it cost to perform a certain challenge. This is a difficult skill. It's not easy. It's a skill that comes with experience and also with training. So it's something to definitely keep in mind. What are the different strategies? What are the different steps that the scientific consultant needs to go through in order to come up with the resolution of this challenge that we talked about? Well, this is a non-linear process, but there are mainly 4 different stages. The first one is usually the planning phase, so that it's important to talk to the customer, collect requirements that they have and details about their starting situation. For instance, it might be that they have a starting data set. They need to explain how the data set was gathered, what's the implications of the data set, and what could be done with it, with the help of the scientific consultant who needs to really understand and quantify these aspects as well. It's also important to compare what is there in the market, what is out there in the market, so that there might be other data sets or there might be other products that might be competition to what your customer wants to do. So it's important to keep in mind also what others are doing. After this planning stage, there is usually a design stage where it's extremely important to start working with project managers from your customer in order to start designing a prototype of the service or product that you want to develop. For instance, your customer might ask for you to develop a program that analyzes tweets on social media. So you need to actually design all the different stages and even the visualizations that will be used by the customer at the end of your consulting. And after the design, it comes the development. You need to develop these features by coding or by interviewing, by gathering more data. The developmental phase is really multifaceted. You might even want to design some specific visualizations, for instance. In case they don't work well, or in case the customer is not happy with them, you need to go back to the design phase. So that's why this is not really a linear component. You go back to the design, you go back to development, and at the end of this process, once the customer is happy with the prototype that you implemented, you really need to show that it works well. So that there is the last stage, that is the deployment. Now, working well is something that we need to think about as complex systems researchers, because usually we produce code, but we don't show whether it's optimized or whether it's it's performing very well with big data sets. So this is a very important stage to keep in mind. Also, another thing that we usually don't think about is putting our code or another software product, for instance, on the cloud, so that the customer can access the code that we produced directly on the cloud and then continue using this. So this is quite important. This is also, cloud deployment is a key skill that might be useful in the future if you want to do scientific consulting in data science. Okay, and now time for a simulation, a little simulation game. A company wants to hire you as a complex system scientist working for a consulting. And there is this question. Please select the option that you decide. In your opinion, what's the must-have skill for consulting? Pick the most important skill that you think a scientific consultant should have. Pick the most important, so just one, the most important skill. I won't vote because otherwise I influence your choices, but I will wait for you to pick your options, and we will see the results and we will comment them. The options are scientific quantitative mindset, strategic and emotional awareness, solid relationship building skills, and the ability to conceive innovative product branding. Okay, so let's see. We are perfectly on time. And let's see the results of the poll. Wow, okay, so it's fascinating that the first three are almost uniform, but the last one is really only 10%. That's very good. So let's talk a little bit more about these four options, okay? So these four skills. The correct answer to this question is actually that they are all must-have skills. So it's important definitely to possess them all up to a certain extent, because they can be useful in with several regards of scientific consultancy. Let's have a look at them. The first one is definitely scientific and quantitative mindset. This is the base starting ground. We as complex systems researchers are trained in having a scientific mindset. From psychology, we know that this mindset comes with certain skills or certain features, like personality traits would be also a good word. Curiosity, being open-minded about new experiences, also possessing critical thinking, understanding when something is working and when something is not, being skeptical about things. And also humility, the ability to understand when something is not wrong, is actually wrong, and you need to change that, scrap that, and start again from another thing. The possessing a quantitative mindset is key for finding innovative ways for new services and new products. And this makes you novel, innovative, and also exciting in the eyes of your potential customer. So this is quite important. And this is also strongly connected with us complex systems researchers, because we can make ties and connections between with topics from different areas, from different disciplines. The second skill that I want to talk about is strategic. It's actually two skills: strategic awareness and emotional awareness. Strategic awareness is the ability to come up with good plans for the future. Remember, we already said that since scientific consultant is paid based on the effort and time that you give, if you give a certain estimate and then you end up doing so much more work, it's possible that you won't be paid for that. So it's definitely important to come up with good plans. Doing strategic choices about how to carefully achieve success. Emotional awareness is also called emotional intelligence. It's a feature like a skill in being able and being aware and being able to manage your own emotions, understand them in order to not be overwhelmed by them. For instance, it might be that in a certain period of time, we are actually quite stressed, or we have anxiety about delivering. But we need to understand that these emotions can be beneficial in motivating us to do better and not be overwhelmed by negativity. This is extremely important if you want to work well under pressure. Of course, again, it's a skill that is difficult to train. It comes up with discipline, exercise, and training. It's also important because being aware of emotions can be useful when we interface with other people. When a customer is angry about something, we need to understand why they are angry rather than just focusing on their negativity. So this is another important skill. There are also two more: solid relationship building skills, networking skills. They are useful also in research, in academia. So I would like to really crush this stereotype of the researcher in the tower that is alone with their own research and they are fine and happy and content with that. It doesn't work that way. You need to build links and connections and collaborations with people that might be collaborators, that might provide training, that might provide funding for your own consulting, but also for your own research. And how to do that? Well, it's a difficult recipe again. It might be, for instance, that you can give inspiring talks in order to attract potential collaborations. You need to be open to other people, to meeting other people. You need to inspire competence, which is also important. Not just being competent, but inspiring it is actually a whole different thing. And this is also, to a certain extent, an intrinsic talent that can be built and can be trained up to a certain extent. The other skill is that is important is media branding and achieving innovative product branding. The customers that might hire you definitely need to be intrigued by your capability or your potential to open new areas of marketing and achieve new types of products. And this is something where complex systems researchers can really shine. We can connect tools and merge expertise models, data sets, data analysis from different areas of different backgrounds, different disciplines under the umbrella of complex systems. And this is key for achieving innovation, which is quite important in the job market. So it's important to explain how your research can have practical impact. Explain and show that through also a little bit of marketing that you can achieve new customers. You can do something novel that other people cannot do. You need to explain this very well, so that it's not important, again, to do only the research, but also to disseminate it and to improve, boost, enhance its impact. And this is good also for scientific consulting as well. Because in scientific consulting, you want to become reputable in something that only you can do. In my case, this was related to a different way of processing language by using complex networks. It might be that in your own research as complex system scientists, you also are filling a gap that is quite unexplored and that might be extremely relevant and interesting for industry or for other types of labels of companies. So a few general level indications on how to improve this aspect. Build up your online presence. Social media can be extremely useful. Actually, I found a few customers through social media. Communicate effectively what you do. Achieve some training in giving good talks, presentations, or in pitching concepts in an easy way, even for people that are not fully trained in science. Build up a portfolio of past consulting gigs that you might have had. Your past customers might give you references in the future in case you want to find new customers. Create also your own logo and motto. This is very much analogous to advertising, but it's important because your logo is usually the first thing that the customer spots. And in my case, it was a mind, since I work with the cognition with a complex network. There is also a little curiosity. This is a star graph, and my surname in Italian means also star. So create something that is personal, that relates to you, not only at a personal level, but also at a certain research and professional level. And then, well, I know that this might be a very strange indications, but actually publishing papers, scientific papers, is a great business card. More and more people with PhDs are being hired in industry and companies. So they are trained in recognizing good level research. They are trained in reading papers and understanding them. Having a paper that shows an innovative product or an innovative way of performing data analysis can be extremely useful for a company to actually get in touch with you because they're interested in what you're doing. And these were like general level indications. There is a little bit of a more quantitative approach to this, especially in the research area of personal branding and sales. There is this model, the IDA model, that was actually introduced quite a long time ago, almost 100 years ago. And this model characterizes the different stages that a certain customer needs to go through from top to bottom in order to be convinced, to become convinced with purchasing a certain service or with acquiring a certain product. So let's start from the top. At the top, there is the level of awareness. So it's important to create a general level of awareness among potential customers about your work. It's important to attract the attention. For instance, you might do this by publishing a paper and by disseminating it on your social media. or your professional social media and social networks. Then, after there is some attention, usually there might be an expression of interest coming from a potential customer. For instance, you might be invited to give a talk at a company about a product that you develop that other people have not been thinking about yet. So it's important to maintain this level of interest, give a good talk, an inspiring talk that also creates desire. The next stage of desire is quite important. You need to be captivating, to captivate the attention of the customer by highlighting the potential innovation and the pros, the strong points of your research, the main advantages, being also honest about your limitations, but definitely showing that you can do something innovative and exciting. If this desire is strong enough and if the conditions are good, then you can proceed to the action phase. That is actually when the customer takes action and provides a service office. And this still needs action on your own side because you need to do a planning in terms of understanding what the customer wants to do and coming up with an invoice, for instance, or a research project that explains exactly what you're going to do and what will be the project fees. Notice that things don't go always well. So it might be that the customer doesn't get enough desire, they go back to being just aware. So this is, again, a non-linear process, especially now that with social media, we can get in touch with so many different customers at the same time. Okay, and now, let's assume that you were successful in your IDA process. You got hired. Congratulations. You perform your job, but research can go wrong, but also consulting can go wrong. Do you think that the scientific consultant should be responsible for issues on their deliverables at the end if something goes wrong? Let's launch the poll. Let's have a look also at the questions. So just select the option that you think is the most correct one, let's say. So the options are, yes, it is their fault if something goes wrong because scientific consultants are paid for delivering. Yes, it is the responsibility to plan ahead and agree on contingency plans with the customer. No, it is not the responsibility. Like in research, scientific consultants can give it one more try. No, it is not their responsibility as long as scientific consultants are frank and honest with the customer. So select the option that you think is the correct one. Let's see a little bit, think a little bit about this. It's definitely a thorny situation, isn't it? It's a bit of a difficult situation. Let's have a look at the results. Very good, fantastic, excellent. So yes, it is their responsibility to plan ahead and agree on contingency plans with the customers. And there is a question in the chat. We will come back at the end of it, okay? So that keep that in mind. The thing is that consultancy comes with freedom, but it comes also with more responsibility than usual research. At least in my experience, this was the case. Because scientific consulting is not it's not research. The customer wants something at the end of the day that actually works. So even though you can be frank and honest with them at the end, it might be that you didn't come up with a backup plan or with a plan B, and that's still your fault. That's still your issue. I see that there is a heated discussion on the chat. We will definitely come back to this at the end of the talk, okay? Usually I can warn you that this is regulated in contracts, so it's not something that you can decide upon. When you start working on something, you need to give some references or some agreements that something, in case something wrong happens, you need to show that you can salvage the consultancy. There might be also additional restrictions that make this different from research. For instance, signing a non-disclosure agreements, so that even though you come up with deliverables that are good, working, even with the technical report, you cannot talk about it because this is private data, for instance, or this was security issues. So this is intellectual property of your customer, not yours anymore. So these are points that are a little bit different compared to research. And also, it's important to come up with a contingency plan at the beginning, being very frank and honest about it, so that the customer can decide whether or not it's worth the effort and risk to perform the consultancy. This contingency plan can be divided in two components, a logistic component showing the different tasks that you're going to do and also outlining the timing, the timetable that you're going to follow. And this is also like, it can be visualized with a Gantt chart that is useful for writing research proposals as well. And it's also extremely important in the beginning to be clear with the customer about the limitations and the scientific limitations of the data that they might want for you to work with. For instance, if you're working with social media data and you usually aggregate them and your product aggregates them, then you need to warn the customer that you are not going to be able to provide longitudinal results about the individual online users in the beginning. Or if the customer already has some data that cannot make it possible to answer some questions or to make some predictions, it's again your responsibility to give them a warning that even though you will be performing some analysis, that will be limited or relying on certain assumptions. In addition to these difficulties, there is also the complex question of research ethics and data science ethics as well. We as complex systems scientists are usually well trained in data science, but not very much into ethics, I find. It's important to bear in mind that in general, there are some restrictions. For instance, if you are in the European Union, or if you work with data, with personal data coming from the European Union, you need to abide to the General Data Protection Regulation, which was introduced in 2018. You might know it as GDPR. And it's a regulation that regulates the rights for individuals to have the data securely stored in anonymous ways. Even the ways that the data must be deleted are actually explained quite in detail in this regulation. There are also some other responsibilities that you have that your hiring institution or your business must abide to. There is also another concern. If you want to perform scientific consultancy and then at the end publish a deliverable that involves data about humans, you might want to have an institutional review board giving approval to your study before you start that. So let's say that a customer wants to gather data about how people perceive a certain topic. If you are affiliated with a university or if the customer has their own institutional review board, you need to apply to them, explaining the methodology that you are going to follow, and they need to give ethics approval. This is a strict requirement. It's becoming more and more strict in the last few years for publishing these results in research venues. It might still not be that strong of a requirement in case the data is used privately by the customer, but there are other types of internal regulations. So it is important always to be aware of before doing the study. Okay, there are some limitations. Why should we bother with scientific consultancy? I believe that it's important to underline that research is not academia. Academia has several management components that do not belong to research. And research itself can be performed also in other types of institutions like research institutions and even industry. So it's important to see that scientific consultancy actually sits in between these two components. And it's good because it can benefit from both the academic environment in terms of getting training, scientific training ideas, pitching results and showing your results and your achievements. But it's also good because it exposes you to the industry. So working with people with different backgrounds, getting potential new problems or data sets, and also finding new novel opportunities for getting research funding. The benefits for scientific consultancy can be useful for the individual consultant. They get training in project pitching, project branding, developing their own ideas, their own research projects. It can be useful also for people in academia, because in this way you can find industrial partners and new types of funding that people might have not thought of. And this is why it's quite nice what the University of Exeter is doing, and I'm really grateful for that. The university has their own consulting company, and they even let employees consult for a limited amount of time through their own scientific consulting business. This is done because the university wants to find new connections and new links with potential industry partners that might provide funding and funding opportunities. And then at the end of the day, it's also good for your research, because Through scientific consulting, you can find novel data sets, work with people from different backgrounds. And I think this is quite exciting also, especially for us, people trained in complex systems science. We have the skills and language for talking and collaborating with people having different backgrounds. Unfortunately, it doesn't always work well. So, for instance, it happened to me. I had a very exciting research project with a very, very good industrial partner. They really liked the idea. I pitched them. I consulted for them in the beginning. We arrived at the stage of writing a grant proposal, and the grant proposal wasn't funded. So it doesn't work always. Actually, it doesn't work many times. And it's important to think that this is still fine, because you can recycle grant proposals or pitch these same ideas to other customers. So a friend of mine always used to say that grant proposals are quite green for the environment because they can be easily recycled. You can also, even through these experiences, you can improve your social network. You still end up working with other people that might be useful for your professional growth in the future. And also, even though the project is not funded, the preliminary research that you do at the beginning might be useful for getting papers or prototypes out of it. Because there is this element of risk, it's important to consider again that scientific consulting comes with responsibility. You are responsible for your own. You should try to juggle many projects and customers at the same time in parallel, if possible. This helps with minimizing the risk of something not going through. But it also takes effort, it takes time, it takes also training. It can be stressful. Okay, it's definitely difficult, but when it works, it's really fun. For instance, one of the most fun consultancies that I had in these past 2 years was my consulting for a spin-off of a university, yrCSS, a Norwegian business working in e-health, in innovation in health. I was called to use my tools with complex networks for modeling the mindset of a small class of students, of Norwegian students, who followed a 3-month training in building this little robot that you see in here that can understand language and can talk in Norwegian, and it's supposed to help doctors in hospitals. So what I did was modeling the mindset of the students before and after the training. I was contacted through my social media by a project manager, Anna Zetseva, and I wrote a project proposal. It got funded. I traveled to Norway twice, and we also wanted to publish, so we had to ask for the IRB approval from the university, and the whole process was also included publishing a paper as a deliverable, and we got it published on PeerJ Computer Science. So this was a very, very nice experience. Okay, let me ask you about another question, the last one, I promise. As a young researcher, I wish I had received more training during my PhD about. Let's launch the poll and let's have a look at the training. So consider what is the skill that you might have wanted to be trained in during your PhD. The options are project management, designing contingency plans and professional ethics, non-disclosure agreements, what they mean, intellectual property, commercial applications, also team management and conflict resolution, or networking and innovation branding. So please think about your PhD experience. Think about what type of skill you might have wanted to be trained in. Let's have a look at your options and your thoughts. I promise I won't gather any data from this, so no IRB approval required. As a young researcher, so I wish I had received more training. It's very much like me, project management, contingency plans, and professional ethics. I think all these aspects are important. So it's definitely important to keep in mind that you need to be trained in networking, innovation branding. I think PhDs should be trained in this also for their research development. Again, also team management and conflict resolution, especially for young researchers. If we want to collaborate with other peers, it might be that in certain teams there are some conflicts that arise. It's perfectly natural. We need to understand how to solve them and achieve success, achieve publication. It's definitely not easy. It takes training. Also, NDAs and intellectual training and intellectual property, they are all specific topics that are specific of project management. So it might be useful for in the future, even when we become in the future supervisors or PhD supervisors to start thinking about inserting project management skills in within the PhD track. So to sum up, I think that even as young researchers progress through their careers, consulting can be helpful in finding new ideas, training, and potential collaborations. This is a process that is similar to the research life cycle of publishing your research. It's also a great training ground because it comes at the cost of being self-disciplined, of being responsible for your own research and research impact. And where to start? Your social network is definitely the best place to start looking for consulting opportunities. Word of mouth can work definitely wonders. And also it's important to improve your social media presence, being as visible as possible. There are also registers and lists of consulting experts that you might want to join as an expert, for instance, in data science. Okay, and thank you so much for your attention. This is the end of the talk. We will now go through the discussion. Before that, shameful advertisement. At the Conference on Complex Systems 2020, I will be hosting the Complexity and Cognition Satellite together with an amazing scientific committee. And we will be having invited talks and contributed talks about cognition, modeling cognition, and using complex systems for doing so. So please join us. Thank you so much for your attention.
Okay, Massimo. Thanks for the very interesting talk. I guess we have time for questions, right? So should I unmute? People could self-unmute if they have questions. So don't be shy or just write them in the chat. So let me just take a look at that.
Okay, so the chat was just about asking
Yeah.
how to vote. Sorry, I thought it was like people commenting on the polls. Okay.
Yeah, not yet. Just let's wait a couple of seconds.
Can I ask you a question?
Yeah, sure. Let me. Okay. Sure.
Thanks. Thank you very much for your presentation. I was wondering if you could tell us something more about if you have like some kind of clients that always with which you're always working, or some, let's say, recurrent questions that they ask you.
Okay.
To
Yeah.
have a more precise idea.
Yes. Yes. So I think like I was lucky enough because I started my consulting because I had a friend of mine that was a friend of a potential customer, and we got in touch, and I started like that. They were they were based in the US, and they were my most recurring customer. I think the most recurring questions were actually related to project management. So, for instance, being extremely careful about the secrecy of the dataset because it was a clinical dataset. So managing that in a certain way, anonymizing the dataset, understanding what type of interventions could be implemented on the dataset. So, and also being extremely careful about the timeline because it was data gathered at certain stages by other people. So I think like the most recurrent questions are definitely like on the project management side, they are based in terms of how to manage the project in a way that guarantees anonymousness, that guarantees non-disclosure details, that guarantees also certain rights for the people who participate in the study. In terms of research questions, instead, I think the most I worked on data on language processing. So the most recurring ones, they were related to this idea of modeling the mind through complex networks. So in my case, the research component was mostly related to what are complex networks and how can they be useful and beneficial for what we want to do with our cognitive data. And I think this also puts us in a very good position because as complex systems scientists, we are trained in complexity science, in explaining complexity science across different backgrounds. So this is something we should capitalize on. And I don't know if I
Totally.
answer your question.
Thanks.
Okay, so do we have other questions?
Can I ask a question as well? Massimo,
Yeah.
thanks so much. If someone else has a question, please go ahead. Mine is a quick one. How, like you mentioned, the marketing aspect, and that's so important because many researchers just assume that everyone else should understand what they do and take it by face value. But frankly, if you say multiplex network to someone, they'll just give you a blank stare unless they know the jargon. But at the same time, there are people who say, you know, can you just make a model to predict the brain and things like that? People who just put a lot of belief in AI and science. How do you navigate that? Because it's in your interest for them to buy your product, but you also don't want to lie. How do you navigate that?
That's a very good question. Yes, there is definitely plenty of excitement about AI and what types of, for instance, in my case, one of my good points was that my models required very minimal machine learning, but they offered more interpretability. So this is something that I was pitching for my customers. But I think it's, again, very, very important not to promise too much. I've seen other people that promise, for instance, that from social media, they were able to understand the perception of the job market all over a certain country or all over a certain area. And this is a little bit limiting because it can be that even social media have their own representativeness issues. Even the data that you work with has their own representativeness issues. So promising too much can also be bad in the long term after the customer realizes that it's not really working well. I think also one way to navigate this well is to show that you validate your procedures. So for instance, I was asked, I developed a product that is called Sentimental that doesn't work in the ways that I never published that. But I was asked by several customers, how good did it work for detecting, for instance, emotions in short text? So they really asked me the number and I had to provide them and tell them, yeah, I tested on this data set, blah, blah, blah. So I think that now industrial partners are becoming more and more well-trained. So it's not just that they are curious about machine learning, they also have employees that are partially competent on them. So they can really, it's good to work with them. And showing that you can validate your product is always a good thing for not promising too much, but at the same time being creating desire in the customer. This is important.
Okay, so Chico, do you want to say something else?
May I ask something?
Yeah. Oh, yeah, sure.
So yeah, my question is, so in industry, well, it's similar to the previous one, but in industry is we hear a lot about AI and machine learning and stuff. However, complex systems and the research we do usually is not so known. How skeptical are people about this? You know, how open to your ideas? And, you know, like telling them, hey, I'm not doing actually machine learning, like I'm doing something different.
I think that the customers are interested in something that is powerful, but something that is also interpretable. So if you can frame what you do in a certain, in an interpretable way, as an interpretable model, they will be interested. It will be definitely difficult. Yeah, I totally agree. When I said, yeah, I have a PhD in complex systems. What's that? So it's difficult, especially in countries like Italy, where we don't have still strong cultural training about complex systems, despite many scientists working in complex systems being Italian and working in Italy as well. So this is definitely difficult, delicate. I think, again, that it's important to show that your product has an easy to understand interpretability and also a validation. I think these are key components. After that, you can train project managers because you will be working with them during the consultancy. You will be working with them, you will update them on the progress that you're having. So there will be opportunities for mutual training and mutual collaborations. I think it's also, again, this falls very nicely in the idea that you need to explain what you do in an easy way. And this is a very difficult skill to acquire, to explain complex issues like, yeah, multiplex network, like complex network, or like machine learning with deep learning. in very easy terms. This is extremely difficult, but sometimes it works. It works well. So unfortunately, I don't have like an easy answer to your concern. This is definitely a challenge that I found and I keep finding in customers. But I think that with these tools, with these instruments, we can approach this in a nice way, in a avoiding conflicts. And again, it's important to plan so that I cannot promise that I will have machine learning that will tell me exactly why people perceive politics in a certain angry way. I cannot do that. I shouldn't do that. Otherwise, I will have problems at the end of the consultancy.
Thanks.
Okay. So do we have other questions?
May I ask a question if you have time?
Yeah. We still have a few minutes.
Yeah, just so a note, sorry, before you ask your question, Tiziana, we still can't hear you. I know you were trying to ask a question, but we cannot hear you at all. So let's this can happen first, and then we will try to get back to you, Tiziana.
Yeah. Okay.
My question is about transitioning from academia into consultancy. What kind of experience did you have when you have this transition? Because academia and private sector are very different worlds. So what kind of an experience did you have?
I think I was lucky enough because I did a 1-year postdoc between my PhD and my start of consulting in an industrial/research institute. It was public, so they did public research, but they did also consulting for private companies. They received funding from private customers. So I think that was a very good training. I did 1 year there. And I also saw like for the first time with my eyes, the procedure of project management and software development through my colleagues. I was exposed to this research. That was like the first start. I also spent some time in the US during my PhD, and that was extremely helpful in, again, understanding how consulting might work for academics. So the transition was a little bit less harsh for me. Of course, it took time. It took time. For the first few months, it was quite hard to come up with strict requirements, being self-disciplined. Also, I set up an office that I didn't have other collaborators, so that was a little bit tough. But I think that my main gratification was that my results and my research and my decisions, my creative decisions, were appreciated by the customer, so that we had some results that were due to my efforts. This is a little bit different compared to academia. In academia, it never ends. You always need to publish more, to do more research, supervise more students, blah, blah, blah. In consultancy, instead, you can really be grateful when a project ends up being successful because of your contribution. So this is a little bit different. It's a little bit tough. You need to be self-disciplined. I think this is not valid for everybody. Research has a great deal of flexibility and intellectual curiosity. Scientific consultancy might have other pros and might have other perks. So it takes a little bit of time, and it might take a little bit of discipline to be able to transition from one stage to another one. Also, this idea that you need to do something that works. This is something that is extremely important for transitioning correctly. But you can also come back. Like from now, my main position is in academia again. So please see these two sides as really being a little bit more flexible than they used to be in the past, especially in data science, if you work in data science.
Okay. So thanks everybody for the questions. And then I guess we can close this session now. And if you have a question for Massimo, for sure you can ask him later.